So when we combine the like terms, we have remember that letter parts have to be identical. We combine the negative 2x squared and the negative 3x squared, which gives us negative 5x squared. Then we combine the 12x and the minus 5x. So 12 minus 5 is 7. So that becomes a positive 7x. And then we have a plus 30 and a plus 17, which gives us 47. So the final correct answer, and I hope everybody did get that, is negative 5x squared plus 7x plus 47. Again, don't forget when it says subtract this A from B, when you rewrite it, the expression that's after the word from is what goes first, and minus the starting. It's just the opposite of the way we say it is the way we write it. Now, let's just remember when we're multiplying two binomials, the method we usually use is called FOIL. First, outer, inner, last. 2x times 3x gives us 6x squared. That's first. Outer is the 2x times the 2 furthest apart. 2x times 2 is 4x. The inner is the negative 5 and the 3x, those that are so close together, which is negative 15x. And the negative 5 times the positive 2 gives me negative 10. When you're multiplying two binomials, you're going to end up with 4 terms because you're multiplying 2 times 2. But what usually happens is that the inner and the outer terms are like terms and they can be combined. So in simplest form, this becomes 6x squared. The 4x and the minus 15x is minus 11x minus 10. That would be your answer. Now, does anybody have any questions on these before we go on? Okay, so I want to do 2 more multiplication examples, and then we're going to go into the topic of today, which is factoring. Okay, I was also having trouble logging in. Okay, I didn't take attendance yet. I'll take attendance a little bit later. I'm gonna do 2 examples just of multiplication, and then I'll give you one to try, and while you're doing that one, I'm going to take attendance. Okay, first of all, we talked about multiplying a monomial times a polynomial, in other words, using the distributive property. And we also talked about multiplying 2 binomials. What if our question was multiplying more than 2 terms? What if I have, let's say, a binomial 2x plus 1 times the trinomial 3x squared minus 5x plus 7. How do I multiply a binomial by any polynomial, or how can I multiply any 2 polynomials together? And all you're really doing is just using the distributive property repeated times. You're going to start with your first term in your first parentheses, which is a 2x, and distribute the 2x to all 3 of the terms in the second parentheses. In other words, I'll multiply the 2x times the 3x squared. So let's do that. 2 times 3 is 6. X times x squared. Remember, when we're multiplying, we're adding those exponents. And no exponent means the exponent is 1. So this is 1 and 2 is x cubed. Then we multiply the 2x times the negative 5x, which gives us negative 10x squared. And then we multiply the 2x times the 7, which gives us 14x. After I've multiplied everything in the second parentheses by this 2x, I go back and I take my second term in my parentheses and do this distributive property with that. In other words, I'm now going to multiply everything by 1. Now, 1 times 3x squared is 3x squared. 1 times negative 5x is minus 5x. And 1 times 7 is 7. In other words, I'm multiplying 2 terms here times 3 terms here, which means that I get a total of 1, 2, 3, 4, 5, 6 terms, 2 times 3. But I have to now look for any like terms. So there's only this 1x cubed, so that's 6x cubed. Then there's a negative 10x squared and a positive 3x squared. Remember, when I'm combining like terms, I just work with the coefficients, the numbers in front. Negative 2 and negative 10 and 3 gives me negative 7x squared. Then I have a 14x and a minus 5x, and 14 minus 5 is 9, so this is 9x plus 7. So it turns out my final answer doesn't have 6 terms, it happens to have 4 terms because of combining the like terms. Okay, let's do one other. What if I had something like this? X minus 5 times x plus 5 times x squared minus 25. See, I had this. In other words, what happens if I am multiplying 3 polynomials? Now we know that actually multiplication is a binomial property. It's an operation that only involves 2 terms. When I'm multiplying, for example, numbers, 4 times 3 times 7, for example. What I have to do is first multiply the first 2 together, 4 times 3, that'll give us 12. And then take the 12 and multiply by the 7 to give us our 84. In other words, we really don't multiply 3 things at once. We multiply 2, get the answer, and then multiply the next. So when I want to multiply, let's say 3 polynomials together, that's exactly what I'm going to do. I'm going to take my first 2 and multiply them together, get that result. And after I multiply that together, then I'm going to multiply it by the 3rd polynomial. So let's see if we can do that. Now, the first thing we should realize is there's something very interesting about this x minus 5 and the x plus 5. These 2 binomials are really identical, except for the sign between the 2 numbers. This has an x minus 5, this has an x plus 5. Let's see what happens when we use FOIL on those 2. We're leaving this out for a minute. So we're going to do x times x, that's first, is x squared. Outer is going to be the 1x times the 5, which will give me a plus 5x. Inner will be the negative 5x times negative 5 times the x, which is negative 5x. And last is going to be negative 5 times positive 5, which is negative 25. And if I combine the like terms, I end up with x squared. The positive 5x cancels with a negative 5x. You know, when you add 2 numbers that are the same number, except one is positive, one is negative, your answer is 0. Basically, it's gone. There are no x's, and minus 25. And usually, when we're multiplying 2 binomials, my answer turns out to be a trinomial. My answer turns out to be 3 terms. But in this case, I multiplied two binomials and my answer was a binomial. This is something we should take into consideration. Why did that happen? Because the two binomials were really identical binomials except with opposite signs. Those are called conjugate binomials. Whenever I have conjugate binomials, and it'll be very easy to recognize if the binomials are conjugate, because you look at them and the two parentheses will look identical, except for the sign between the two terms. One will have a plus, one will have a minus. If when you have conjugate binomials and you're multiplying them, you can save yourself some time, because it will always turn out that the outer and the inner will cancel each other out. And therefore, your answer will not be a trinomial, but a binomial. So if I would have noticed that right away in the beginning, I would have seen x times x is x squared. Oh, it's conjugates. I don't have to do inner and outer. I just have to do last. -5 times +5 is -25. And I would have right away gotten my answer, x squared minus 25. So that was an interesting thing to know. Notice we're now multiplying these two binomials. We now want to multiply the third thing. I now want to multiply it by this third binomial, which is actually happens to be x squared minus 25. Now, these two are not conjugates because they are actually identical. We are actually asking us to square x squared minus 25. It's as if we had taken the parentheses and put a 2 exponent there. X squared minus 25 squared really means x squared minus 25 times x squared minus 25. And when you're squaring a binomial, you actually have to rewrite it. You have to write each binomial separately. And now, no shortcuts here. We actually have to do FOIL. They're not conjugates, so we have to actually do the FOIL. So let's do it. First, x squared times x squared is x fourth. Remember, 2 and 2 is 4. Outer is x squared times -25, which is -25 x squared. Inner, -25 times x squared is -25 x squared. Notice both of these are -25 x squared. So it's not one positive and one negative. And the last is -25 times -25. Now, a negative times a negative is positive, and it's 625. And the only thing I'm left to do is to combine these like terms. The x fourth stays. The -25 x squared and the -25 x squared gives me -50 x squared plus 625. Okay, so we learned a couple of interesting things here. First of all, that if we end up multiplying 3 polynomials, we just do it, multiply the first 2 together, get your answer, multiply by the third. That's number 1. And number 2, that if we end up multiplying conjugates, we can save ourselves time, because when we multiply conjugates, conjugate binomials, which are binomials that are identical except for the sign between the two terms, then we can save ourselves some time by just multiplying the first together and the last together. The outer and the inner for sure will cancel out. Okay. So I'm going to give you now one multiplication example to try on your own. And while you're doing that, I'm going to be taking attendance, so listen for your name as well. So let's see if you do this. 3x minus 5 times 2x squared minus 4x plus 3. See if you can multiply this binomial by this trinomial. Well, I'm taking it 10 minutes. Maury here. Chelsea. Okay, Maury, thank you. Good afternoon. Chelsea here. Chelsea here. Ariana.
Here. Good morning or good afternoon.
Good afternoon already, yeah. I don't know where that morning went, but it's gone. Adina.
Here.
Hi, how are you? Lachey.
Here.
Hi.
Here.
Kava. Kava here.
Here.
Hi, okay. Terrence.
Here.
Hi.
Hi.
Karide. Karide. I know you. I know you here. Kizia.
Here.
Faith. Faith Biggs.
Here.
Hi. Ethan.
Here.
Hi. Isabella.
Here.
Hi. Serenity. Serenity here. Reggie. Reggie Gomez.
Here.
Hi.
Hello.
Zamia.
Here.
Hi. Brandon.
Here.
Hi. Michaela.
Here.
Hi. Seraphine.
I'm here.
Hi. Marissa. Hi. Renee.
Here.
Hi. Sky. Sky Powell. Jaden. Jaden Roberts. Kennedy. Okay, Sky, I see you. Okay. Kennedy here. Kennedy Shell. Hi, wait. Oh, here. Thank you, Adina. You're always on the ball. Felicia. Felicia. Natalia.
Here.
Okay, and I see Felicia, you're here. Okay, Michael.
Here.
Hi. Cassidy.
Here.
Megan. Hi, Megan. Kalia? Kalia? Lauren?
Here.
Hi, Lauren. And Kayla Zachary. Kayla? Well, this is a good class. Most people show up. Okay, let's do this problem now. I see some people already came up with the answer, so let's work on it. Again, since it's a binomial times a trinomial, we'll first multiply everything in the second parentheses by the 3x, then we'll go back and multiply everything by the -5, and then we'll combine the like terms. So 3x times 2x squared is 6x to the third. 3x times -4 is minus 12x squared. And 3x times 3 is positive 9x. Okay, so we've taken care of the 3x. Now we're going to the -5. -5 times 2x squared is negative 10x squared. -5 times 4x is positive 20x. And -5 times 3 is minus 15. Okay, I've done all my multiplications. I can tell that I've done them all because I have 1, 2, 3, 4, 5, 6 terms. Now I look for those like terms. So there's just the 6x to the third, the negative 12x squared, and the negative 10x squared. Of course, you have to know how to combine like terms, is negative 22x squared. Positive 9x and positive 20x gives us positive 29x and minus 15. And that should have been your answer in simplest form. The only, is that a plus 20? Looks good. Adina, looks very good. Okay, and a couple of other people, thank you. So that's basically the multiplication. We're now going on to the next step. We did adding, subtracting, and multiplying. If you recall what I said, in this chapter, we don't talk about division of polynomials. We actually talk about something called factoring of polynomials. Let me give you an idea of what is the difference between dividing polynomials and factoring polynomials by discussing it in terms of just regular numbers. The difference between factoring and dividing. I could give you a question like this, divide. Take 20 and divide it by 3. Now, on your calculator, you could put it into your calculator. 20 divided by 3. You could also write it as 20 over 3. And actually, there's not much more you can do with this unless you want an answer in decimal form. If you want an answer in decimal form, then you would get 6.666. It actually goes on forever, or you could do round it off, 6.667. They're actually, that's what dividing is. When you divide, you don't always get a nice answer. Now, sometimes when you divide, suppose I had 20 divided by 2, then my answer would be 10. Sometimes when we divide, we get whole numbers. Nothing, no remainders, no fractions, no decimals, whole numbers. What we usually say then is that 2 is a factor of 20. When something divides evenly into a number, it becomes a factor. And even though you can divide with numbers that are not factors, of course, when you're dividing with numbers that are factor, you get much nicer answers. Now, one of the things that we're asked to do with factoring is, let's say I gave you an example like this. Find the factors of 15. Now, I'm not telling you what to divide the 15 by. When I say find the factors of 15, what I'm asking you to do is to try and figure out what numbers originally, what whole numbers did you originally use to get 15 as an answer. And we know that one of the factors of 15, we might know, is 5. Because we know that when we divide 15 by 5, we come up with a whole number. The answer is 3. Once you know one of the factors of a number, then you can use division to find the other factor. In other words, if I know 5 is a factor of 15, all I have to do is divide the 15 by 5. That'll give you 3, and you know your two factors of 15 are 5 and 3. So when you're looking for factors, you're looking for two numbers that when you originally multiply them, gave you this answer. Does it involve some division? Yeah, a little bit it does, but it's not the same as the operation of division, because when you're dividing, you can divide any two numbers. But when you're looking for factors, you might have a number that has no factors other than itself and 1. That's what's called a prime number. So the same thing is going to happen when we have polynomials. We're going to be looking for factors of polynomials. We're going to be looking for two things that when we multiply them will give us the answer. We're going back. What did we originally multiply to get the answer? As I said, in the next chapter, we're going to talk about division of polynomials, but that's really an entirely different thing. Now, it turns out when we're doing factoring of polynomials, there are a number of different ways we could factor something. So what I'm going to do is I'm going to tell you what you start with, what do you look for initially, and the different ways you might accomplish this. And I want to put it in a specific order so that you'll know when you want to go to factor polynomials, this is what you do first. If that doesn't work, then you go to this method. If that doesn't work, you go to the third method. But there's always a protocol as to how to approach a factoring problem. So the first type of factoring that we look for is sometimes called the GCF, or greatest common factor, or greatest or a common monomial factor. Basically, I'm going to shorten it and say we're looking for a common factor. Now, what does it mean when we find we're looking for a common factor? So let's say I have an example that looks like this. Suppose I gave you a binomial 9a squared b minus 6ab squared. Okay, it happens to be a binomial, but it could be a trinomial, it could be any number of terms. The only type of factoring you can do with as few as 2 and as many as 100 that we can do is something that's called finding a common factor. And finding this common factor is always the first step we want to do when we are looking to factor an expression. So how do we go about doing this? We look first of all, we look at the coefficients, the 9 and the 6, and we look for a number that the largest number that we can figure out that goes into both 9 and 6. And I guess everybody realizes it's going to be a 3, and we put it down. Notice if the leading coefficient, that means the first term, is negative, part of the GCF, part of the greatest common factor, is that negative. In this case, it's a positive number, so we're only using a positive number. So that's the first thing. Look for a common factor of your coefficients. And if you had 20 terms, you'd have to look for a number that goes into all 20 terms. Then you start with the variables, the letters. And the first letter we have here is an A. This is an A squared, and this is an A, which is an A to the 1. If there's no exponent, it's understood to be 1. The greatest common factor is always the one with the lower exponent. So the letters are easy. Take the lower exponent. If not all terms have an A in it, then A is not, there's no common factor with an A. But if every single term has an A in it, just look for the one with the lowest exponent. That's going to be your common factor. So in this case, my greatest common factor on the A's is just a plain A. Then you go to the next letter, which in this case is B. There's a B and a B squared. Again, the lower exponent is 1. It's B to the 1. So your B is part of your greatest common factor. So 3AB is the greatest common factor of both of these terms. Once you have that common factor, you've gotten half the bound. It's like with the number 15, we knew one number was 5. How did we find the other number? We took the 15 and divided by 5. We're going to do the same thing here. To find the other factor, what we do is we take this greatest common factor and divide it into each term. So I divide the 3 into 9 gives me 3. The A into A squared. Remember, when you're dividing, you're subtracting exponents. So this is an exponent of 2 minus an exponent of 1, which is 1. So it's A to the 1, which is just A. And the B into the B, now, if you subtract their exponents, you're going to get a 0. That literally means that you have 1. Anything to the 0 power is just the number 1. So therefore, there should be a 1 here, but 3A times 1 is just 3A. So in other words, the B canceled out. Let me just make a comment. If every single thing cancels out, it doesn't all disappear, you're left with a 1. If some things cancel out and some things don't, then you're just left with those letters and numbers. So when I divided the 3AB into 9A squared B, I got 3A. Now I go and do the same thing with the second term. 3 into negative 6 is negative 2. Now the A's cancel out because there's 1 minus 1 is 0. But the B into the B squared is B. So factoring out the greatest common factor gave me my final answer to be 3AB times 3A minus 2B. We have factored this polynomial. Okay, I'm going to give you one to try now. See if you can do this one. 6x fourth y squared minus 18x cubed y cubed plus 3 x cubed y squared. Let's see if you can't factor out the greatest common factor. Okay, I think we have had enough time to try this. Let's see if we can factor it. Again, even though this is three terms, the idea is the same. We look for a greatest common factor. So I have a 6, an 18, and a 3. The number that goes into all three of it is obviously 3. So I put that down. Then I go to the variables, x fourth, x third, x third. The lowest one is x third, so I'm going to put that down. Then I go to the y's, y squared, y third, y squared. The lowest one on there is the y squared. So my greatest common factor is 3x cubed y squared. Now I have to find what goes in the other polynomial. This is the monomial, now we're going to the polynomial. I divide 3 into 6, that gives me 2. The x cubed into the x fourth, 4 minus 3 is 1. That gives me x to the 1, which is just plain x. The y squared into the y squared cancels out. Remember, when the exponent turns out to be 0, it's canceled out. Go to the next term. 3 into negative 18 is negative 6. X cubed into x cubed cancels out. Y squared into y cubed gives me y, because 3 minus 2 is 1. And finally, I do 3 into 3, it cancels out. X cubed into x cubed cancels out. Y squared into y squared cancels out. Everything here, this went into this. Exactly. When everything cancels out, I have to put a +1. There were 3 terms here, so my polynomial inside has to be 3 terms. Do not forget that one. That's a common mistake. Don't make that mistake. Okay, great. So that's the first type of factoring we looked for, is a greatest, a common monomial factor. One, a single term that will go in evenly into each term. Now, there actually are things that are called, by the say, thank you, Reggie, that was very good. Just write this down. This was a common factor. I'm good. Since I'm going to mostly call it a common factor, I may as well just write that instead of the letters. Okay. Sometimes we even have a common binomial factor. You might see something like this. 5a times x minus 2 plus 6b times x minus 2. You might see something that looks like it's partially factored already. And instead of trying to get rid of the parentheses or anything, what you notice is that both the 5a and the 6b are being multiplied by this expression x minus 2. X minus 2 is a factor. Remember, a factor means you're multiplying. It's a factor of this term and of this term. So what I could do is factor out the x minus 2. In other words, put the x minus 2 in front, and in the second parentheses, just put the two expressions that were in front of this. The first is going to be the 5a, the second is going to be the 6b. This is saying that x minus 2 is being multiplied by both the 5a and the 6b, which is exactly what this says. This is a common factor as well, but it's not a common monomial factor, it's a common binomial factor. This type of situation doesn't happen so often, except that it could be useful in something called factoring by grouping, which is the second type of factoring that I want to speak about today. Okay, so we talked about a common factor. Let's now talk about factoring by grouping, and let me show you how that works. So this is the next type of factoring we're going to be talking about. We do factoring by grouping basically when we have an expression that has 4 terms. A polynomial, we don't call it a trinomial because it's got 4 terms. It doesn't have just 3 terms. Let's say I have something that looks like this. Three x y squared minus 6y squared was 4x minus 8. I have this polynomial that consists of 4 terms. And of course, the first thing I always going to be looking for when I want to go to factor a polynomial is to see, is there a common factor in this whole polynomial? Well, if I look at the coefficients, this is 3 and 6 and 4 and 8, there's no one number that goes into all 4 of those. And in terms of the letters, there's an x here, but this doesn't have any x, so x can't be a common factor. And this has a y, and this has a y, but this has no y, so there's no common factors of y. So there's no letter or number that's a common factor of the whole expression. When that happens, what we do is, doesn't always work, but we try something called grouping. In other words, group your 2 first terms together, group your second 2 terms together. Since there's 4 terms, you have 2 groups, two binomials. Look first at the first group, 3x squared, xy squared minus 6y squared. Is there a common factor in that group? And yes, I see, first of all, between the 3 and the 6, 3. There's no x, but y squared is in both of them, so 3y squared is a common factor of those first 2 terms. And what we get from that, after we factor out that 3y squared, well, here the 3 cancels, and the y squared cancels, so the first term becomes an x. And then the 3 into the -6 gives me -2. The y squares cancel out. In other words, if I just take the first two terms together, I can factor that into 3y squared as my common factor times x minus 2. I then go to my second group, which is the 4x minus 8. And look if there's a common factor in that group. Well, there's a 4 goes into both of them. And since this first term is positive, the common factor is a plus 4. And if I factor out the 4, I get 4 into 4x gives me x. And 4 into -8 gives me -2. Now I can erase this thing and look at it. So if I took my two groups separately and I factored each of the groups separately, it turned out, and this doesn't always happen, but if it does happen, that we got a common binomial factor. The x minus 2 is a factor in the first group, x minus 2 is a factor in the second group. So we can do what we did before with our common binomial factor. We'll put the x minus 2 first. And then in the second parentheses, we'll put the 3y squared plus 4. So that we were able to take this 4-termed expression and break it up into two binomials, x minus 2 times 3y squared plus 4. That is what's called grouping, factoring by grouping. Again, when do you use it? When you have 4 terms, so that you can group together your first 2 terms and your second 2 terms. Do you think you're ready to try one on your own? Okay, here, I'm going to put one on the board. P to the third minus 2p squared minus 15p plus 30. Let's see if you could factor this by grouping. I'll give you a few minutes and then we'll do it together. Okay, let's see if we can do this together. Again, there isn't a p that's a common factor of everything. And there's no number that's a common factor of everything. So again, we're going to group. We're going to take the first 2 as one group, the second 2 as our second group, and see if grouping will help us. Again, with grouping, we always look at a common factor of the first 2. So this is a p third to the 3 and a minus p squared. So our common factor is p to the second, because that's lower exponent. I'm gonna put a p squared on the outside, and p squared into p to the third, 3 minus 2 is 1, so that's just plain p. And p squared into p, negative 2p squared, the p squareds cancel out, and that gives me p minus 2. That's my first group. Common factor in my first group. Okay, now I go to my second group, which is a negative 15p plus 30. Okay, so first of all, the first number in the group, the leading coefficient of the group is negative 15. Remember what I said, when your leading group number, your leading coefficient is negative, you include the negative as part of your common factor. So since this is 15 and 30, I'm not going to do plus 15, I'm going to do negative 15. My common factor is negative 15. And when I do the negative 15 into the negative 15p, I'm left with just a p. And when I divide the negative 15 into the positive 30, it gives me negative 2. So I'm left with okay, good. Those a couple of people are getting these right away. So now, after I've grouped it, I see that I have a common binomial factor of p minus 2. So I put the p minus 2 in front, and then what goes in the second parentheses is the p squared from the first one and the minus 15 from the second one. And again, I've taken my 4-termed expression and broken it down into 2 binomials. This is what's called factoring by grouping. Okay. So now we've done 2 types of factoring. Common factors, which can be either a common binomial or a common monomial factor. Again, in that case, you can have as many terms as you like. The second type we did was something called grouping, specifically used when we have 4 terms. It doesn't always work, but sometimes you can't always factor an expression, but if you have 4 terms, try grouping and see if it works. So now I want to do another type of factoring. This type of factoring is called finding the difference of squares. You're going to have a binomial. In other words, there's going to be only 2 terms in these type of examples. In other words, you're going to know whether you should try grouping or difference of squares type of factoring simply by how many terms your expression has. If you have 4 terms, you're not going to try difference of squares. If you have 2 terms, you're not going to try grouping. So it's very clear which method you're going to use. What does difference of squares mean? Each term in your binomial is a perfect square. In other words, you might have something like 25x squared minus 49. 25x squared is a perfect square. It's 5x times 5x. 49 is a perfect square. It's 7 times 7. And it has to be the difference, which means the sign in between it has to be a minus. If you have that situation, if you have a binomial that is a difference of squares, then you can factor, this is just a matter of looking at the pattern. You can factor this into 2 conjugate binomials. You take the 25x squared and take its square root, 5x and 5x, and put it in the front. Then you take the square root of the second term, 49, the square root is 7 and 7. And then in one parentheses, you put a plus, and in one parentheses, you put a minus. And you have factored this. Notice your factors are what we call conjugate binomials. Let's remember what we said when we multiply conjugate binomials. When your binomials are conjugate, in other words, they look identical, except one has a plus between the two terms and one has a minus. When you multiply them, you don't have to do the whole FOIL because the outer and the inner terms cancel each other out. So 5x times 5x would give you the 25x squared. The outer is negative 35x and the inner is plus 35x. Those cancel out. That's why we don't have to bother with it. And the last term is 7 times negative 7, which is negative 49. So when you see a binomial that is the difference of squares, you know it always came from multiplying two conjugate binomials. And all you have to do to factor it is to go back to those conjugate binomials. Again, step 1, look for a common factor. Step 2, well, let's see. If it's 4 terms, try to group it. If it's 2 terms, see if it's a difference of squares. I'm going to give you one to try now on your own. Let's say I gave you 100x squared minus 25y squared. Suppose I gave you this and I said, I want you to factor that. Okay, I want you to think about it and then we'll do it together.